Now coming to the second one, the general loader scheme. As you have already learned about the compile and go loader. So in the compile and go loader, you have the assembler which is going to reside into the memory. So because of this, there is a waste of memory within the core. Now, outputting the instructions and data as they are assembled creates the problem of wasting the core for the assembler. Such an output can be saved and loaded whenever the code has to be executed. So, these assembled programs are loaded into the same area in the core that the assembler is occupied. So this output form, which may be on cards containing a coded form of instruction, is called as an object code. Now coming to overcome this, we require an addition of new program of the system that is nothing but a loader. This loader is assumed to be smaller than the assembler so that more memory is available to the end user. The loader accepts the assembled machine instructions and data in the core in an executable format, and then it reassembles it and it in order to run the program in the later stage. As you see in the diagram of general loader scheme, we have two programs, that is nothing but the source program, that is source program 1 and 2, and then these two programs are connected to the translator. It can be either a compiler or an assembler, wherein they convert the source program into the object program. So we have two object programs which are being generated from two source programs, and then combined together these two are linked and loaded onto the loader. The loader is going to accept the object programs and then place the object programs for execution. Now as you see in the diagram there is no assembler which is residing into the core. So instead of that, we have the loader which is available into the memory. So this loader is smaller when compared to the assembler. Thereby, the size of the memory is going to be utilized by the end user. Now coming to the advantages of general loader scheme, it is smaller than the assembler. It doesn't require any reassembling, and it is possible to write subroutines in different languages. And there is no wastage of memory as the assembler is not residing in the memory. Now, what are the disadvantages? Disadvantages is nothing but the loader is being occupied in the main memory, wherein it requires a very minimal amount of space when compared to the assembler. The simplest type of loader scheme which fits into the general loader scheme is called as an absolute loader. The absolute loader is one kind of loader in which relocated object files are created, and then it accepts these files and places them at a specified location in the memory. It's called as absolute loader because there is no relocating information which is needed, rather than it is obtained from the programmer or the assembler. In this scheme, the assembler outputs the machine language translation of the source program in almost the same manner as in the form of compile and go loader, except that the data is being punched onto the cards, which is being directly placed into the memory. The resolution of external references or the linking of different subroutines are the issues which are to be handled by the program. The loader, in turn, simply accepts the machine language text and places it into the core at the location prescribed by the assembler. So this scheme makes the available of the core to the maximum extent to the user since the assembler is not in the memory at the load time. The programmer should take care of the two things mainly. The first thing is specification of the starting address of each module to be used, and secondly, while branching from one segment to another, the absolute starting address of the respective module is to be known by the program. As you see in the diagram, we have two programs. One is called as the main, the other one is a square root subroutine program, and this is being fed to the absolute loader. So the absolute loader places this onto the memory with respect to the main program as well as the square root which is being shown in the program. The main program is assigned to locations 100 to 247 and the square root program with the locations 400 to 477. If we make any changes to the main program which increases the length of the program to more than 300 bytes, then the end of the main program will be 400, which will overlap the starting address of the square root program which starts at 400 location. So this will be necessary to assign the square root program to a new location by changing its start sudo op and then reassembling it. So therefore, it would be necessary to modify all other subroutine programs that are going to be referred to the address of the square root. So in such situations wherein we have more number of subroutines which are going to be used in the program, and then this has to be reshuffled in order to remove the overlapping of the program. So whereby this indicates a very complex, tedious as well as the waste of the core. The advantages of absolute loader scheme are it is simple and efficient. The disadvantages are the programmer must specify to the assembler the address where exactly the program has to be loaded, and then if there are multiple subroutines, then the programmer must remember the address of each of the subroutine programs.